The third planet from the Sun lies our home, the planet Earth. In a fragile balance, it sustains all living things with its vast oceans, land masses, snow, ice, and atmosphere. Since the beginning of recorded time, humanity has tried to better understand and make use of the environment by observing and exploring the surroundings. Today, we continue to do so at a global scale under a field of study called remote sensing, which is simply observing an object or a collection of objects of interest from a distance with the help of eyes or sensors that observe the electromagnetic spectrum. One of our primary tools for observing our environment are remote sensing satellites. With their sensors, they can see or sense reflected light from our oceans, land, and atmosphere, and help monitor their condition along with many living organisms that live within them. These satellites help us understand the overall state of health and condition of our planet. But seeing the big picture with satellites has its drawbacks. You can't detect small details. One way to fill in some of the details is to place sensors on airplanes and fly them at the same time a satellite passes overhead. By doing this, we can fill in with more detail the satellite pixels which are seen here as a single color over the ocean. But this is not the end of the remote sensing story. Unfortunately, these eyes, or sensors on satellites and planes, do not have brains behind them to make sense of what they are detecting. We must therefore make direct measurements on the ground, in a process called ground truthing, to associate what is really there and what the remote sensing sensors are detecting, and at the same time make corrections, called calibration, to the data gathered by these sensors to get more accurate measurements. We also make sure of the location of what is being detected by aerial and spaceborne sensors by using the Global Positioning System, or GPS. So here's the big picture of remote sensing. We have multiple sensors on satellites flying at about 7 kilometers per second above the Earth, gathering data over vast areas. At the same time, an airplane flying over the same area of interest, gathering more detailed data, or what is called higher resolution data. And finally, you have a person doing ground truthing, collecting information that will be used to help validate and calibrate aerial and spaceborne remote sensing instruments. Now, all this seems like a lot of work, and it is. But through global and local remote sensing, we can have a much better understanding of global scale phenomenon as well as what is happening in our own backyard. We can also quickly notice any changes to our environment, such as hurricanes, forest fires, or floods, or study global activity or changes over long periods of time, such as El Niño, crop growth, pollution, and ocean life. By simply having this information, we as people can make better informed decisions and help us maintain nature's fragile balance and at times better prepare ourselves for the unexpected forces of nature.